Let's get starting right away on the presentation. As Matilda mentioned, my name is Laurenzo, technical specialist with ICA delegation in Suriname. I'll be presenting the Climate Smart Technology project that has been done in a year ago. And let's see. The presentation layout for today, we'll have the project summary, an objective, the main activities, deliverables, achievements, summary farmers experience, and the positive agroecological practices and benefits. The project title is Vulnerable to Climate Impacts through the Promotion of Climate Smart Agriculture. And it was a budget amount of 266,087 with an implementation duration of 80 months. It was an initiative under the GCCA Plus Suriname Adaptation Project funded by the European Union in collaboration with the UNDP Suriname. The overall objective of this project was to strengthen the resilience of the agriculture sector in Suriname to the negative impacts of climate change through the promotion and use of climate smart agriculture technologies, with specific objectives targeting farmers, reducing farmers' vulnerability to climate change impacts through the building of knowledge and skills in the use and management of protected agriculture structures, micro-irrigation, and rainwater harvesting system for sustainable commercial sustainable production. The project itself was implemented at the area called Wegnar Sea, located on the northwest of the capital, Paramaribo. As the name suggested, it is on the Atlantic coast. It's one of the main vegetable producing area of Suriname with a population of 16,037, according to a census held in 2012. The main activities under the project, we could divide it in two main activities where we had the establishment of protected agriculture structure, the setup of micro-irrigation systems, and rainwater harvesting system completed with water reservoir with a capacity of 480,000 liters. The second component had a lot to do with the development of on-farm training modules in the use and management of the protected agriculture structure, the maintenance of the protected agriculture structures, the setup, the design, and the use and management of micro-irrigation systems, and also on-farm training on management of soil and water. As mentioned, one of the deliverables are that we were able to establish two protected agriculture structure. The model used was the double ridge protected agriculture structure with a dimension of 45 meters by 9 meters by 7.5 high. These models have normally high side walls, so it will also already increase your air circulation inside the protected agriculture. But what you really want is to have a better management of temperature and humidity. Therefore, this structure has two horizontal flow fan and 4 cooling fan installed, together with a misting system that is being triggered by a sensor system. The moment temperature rises, it will trigger it, and you will see that the temperature will go down and cool the whole system inside. The crop production method used was on basis of hydroponic production system, soilless culture, and the whole protected agriculture structure is also covered to keep with anti-insect netting to keep pests and diseases off. The substrate used was locally produced with local material, local source materials such as river sand and rice chaff. The ratio was calculated based on the bulk density of each material. Both system was totally run by solar energy with a capacity, a solar system with a capacity of 60 kilowatt. I must mention that every additional energy that was not used are being sent to the local electrical company which gave the farmer a discount on his monthly electrical bill, household bill. On the side of the protected agriculture structure, you will find a guttering system that collects all rainwater from the roof and stored in a water reservoir with a capacity of 480,000 liters. This reservoir is further lined with a pond liner, the HDPE pond liner, to protect your water from groundwater contamination or by saltwater intrusion. In regards of the micro irrigation systems, we have installed 2 micro irrigation systems, the micro overhead sprinkler on an area of 4,000 square meters for the leafy vegetable production, and drip tube irrigation systems on an area of 2,000 square meters for vegetable productions like tomatoes, sweet pepper. Both systems were completed with fertilizers injectors and primary and secondary filter to prevent your emitters to clogging. The fertilizer injector allows you actually to calculate the right amount of nutrition required per growing stage of your crop, and also minimize nutrition loss by runoff, which works well because if you have a lot of inefficiency when you calculate the fertilizer of using fertilizer, your cost of production will just go up and go up. In regards of rainwater harvesting reservoir, we have installed 3 of the same sizes each on different type of soil. Different materials were used. I'm saying that because depending on the type of soil, you would need to calculate the right angle of the slopes. So you have a solid wall for your water reservoir, and also depending on the location, you would have to calculate your dike around your water reservoir. Depending on the size, you could ask the supplier also to provide you with a one-piece pond liner, or you could ask the supplier for sheets. So they will give you rolls which you would need to weld on site, but therefore you would need an additional tools to weld these sheets together. So you have a clean pond liner without any gaps between the seal. Some other achievements under the project was that we could have trained 121 farmers, 22 agriculture extension officers, 21 students of the Community University of the Agriculture Department on open field micro irrigation and crop management on the protected agriculture structure. Several farmers and agriculture technicians participated on the North Center of Research in Santa Anita, Jalisco, Mexico. Also, one video has been produced on climate change and climate smart technologies. You could find this video on the YouTube channel. Farmers, when you introduce them to new technologies, they will also establish plots to compare what they are doing and what they are introduced into. Therefore, farmers have done visual observation and simple data collection of fields between agriculture structure production and open field. They have checked on the harvesting time. They noticed that they could have harvest till 12 months under protected agriculture condition, and open field, they had 3 months of harvest of this of sweet potato. Weekly fruit set on the per plant on the protected agriculture structure, they noticed it was higher. And on the open field condition, it was lower. The quality of fruits on the protected agriculture structure, they didn't detect sunburn and open field condition, the sunburn were present. In regards of the fertilizer, the plants react faster, and on the open field conditions, the plant reacts slower. Washing harvest fruit on the protected agriculture structure wasn't necessary. The fruits were clean. You could basically eat it right away out of the plant. The open field conditions you would require washing the fruits before consuming. Yield per plant on the protected agriculture structure were higher and on the open field was lower. The taste was sweeter on the protected agriculture structure and slightly bitter on the open field conditions. Regards of the positive agroecological practices and benefits, by using rice chaff as a growth substrate, here in Suriname, we are used to burn rice chaff that cause, CO2 emissions. The growth substrate can be reused for open field soil amendment for amelioration upon replacement. By collecting all rainwater harvesting, you have quality water for irrigation. The micro irrigation systems are compared to the one that we are using, what they are using or normally using is 85 to 100% more efficient compared to a 60% with the method that we are using now and than before. Reduce of pesticide weedicide due to soil culture, soilless culture and protective cultivation environment. More efficient use of fertilizers through hydroponic system, which reduce leaching of agrochemicals into soil and groundwater sources. Reservoir with protective lining protects stored irrigation water from contamination by saltwater intrusion. Reduce crop losses due to reduced incidence of weed. We use ground cover in the protected agriculture structure. Reduce incidence of pest and disease. The whole protected agriculture structure was fully closed with anti-insect netting. Reduced impact of environmental factors due to controlled environment, sunburn, shade netting also was included. Nutrition and moisture deficiency disorder and chemical injuries. I think with this slide, I've ended the experience that we had in the field and looking forward to the discussion later on.